Welcome to the Fire Environment Continuing Education SubCommittee webinar. This is our first of a new series we're trying to offer, at least testing out single topic, monthly webinars where we kind of drill down deeper into a single topic for the time. Today, our presentation will be on FlamMap 6 by Chuck McHugh. And we are recording this webinar, and we will have it posted on the NWCG webpage. To start us out here, I'm just going to go through a little bit of who we are as far as the Fire Environment Continuing Education Subcommittee. We are a small group of professional experts, and where we seek solutions and provide a platform amongst a larger group of topics such as fire behavior, fire occurrence, fire weather, smoke, and risk assessment tools. You may have previously joined one of our biannual webinars that we hosted in the past. Like I said, we're offering this new kind of single topic monthly webinar format to see how it goes. I am the chair, Wesley Hall, for the Fire Environment Continuing Education Subcommittee. We are a subcommittee underneath FCESC, which is the Fire Environment National Committee under NWCG. A little bit on the webinar rules, and then we'll get started here. For questions for this webinar, please use the chat feature when possible. Also, this is more of a workshop format, so you are welcome to raise your hand, and then when we call upon you, go ahead and unmute, and you can talk or ask your question that way. When you're not talking or asking a question, please stay on mute during the presentation. Also, please keep your webcam off during the presentation so that we can maintain bandwidth, and hopefully we don't have any big glitches in the webinar here. This is our first time to use this Teams webinar format, so please excuse us if we do run into any technical issues. We're trying the new format to see how it goes. Hopefully it'll go smoothly here. Fingers crossed. Any questions that are not answered during the presentation, we will answer via email after the conclusion of the webinar. And then the webinar will be recorded and posted on the FCESC webpage under NWCG there. The link is right there in the webinar. And you can also do a Google search for us as well. Today's presenter will be Chuck McHugh. Chuck currently works as a fire spatial analyst in the Fire, Fuel, and Smoke Science program at Rocky Mountain Research Station in the Fire Sciences Lab in Missoula, Montana. Chuck is the FlamMap program coordinator and oversees the development and support of the application. During normal fire season, Chuck is a long-term fire analyst in LTAN, like many of us are, and he supports wildland fire management at the national, regional, and local levels. Welcome, Chuck, and thank you for joining us today. And at that, Chuck, I'm going to go ahead and pass the presentation to you and let you get started.
Okay, thanks, Wes. So I want to thank everyone for taking time out of their day to come learn about a little bit deeper dive about FlamMap. We're going to spend a little time here talking about how do you FlamMap is what I called it. And none of the work I do would be possible first without all the effort and work that Mark Finney did to develop all these applications. Then I need to acknowledge two other people who are critical to FlamMap's continued support, development, and delivery, and that's Stu Britton, who does all the coding for the application, and then Rob Seeley, who helps with the development of the help file and all of that. Without those two people helping me, FlamMap wouldn't be where it is right now today. A quick outline, I'm just going to do some introduction, talk about a couple of things related to modeling errors, where and how you get FlamMap, because oftentimes people join on to these webinars and you never really know who or how they're going to what their experience level is. And I'm going to spend some time talking about our help and tutorial files as resources, go over 2 new things that have come out with 6.2 Spatial FOFM, which is taking the desktop FOFM and making it spatial. But that's about all I'm going to mention with it, because with everything else to cover, we won't have time. And spatial FOFM is like would be its own topic and discussion for a later date. Talk about a get landscape utility that's embedded within FlamMap now to help assist getting landscape files. We're going to go over setting up runs and data discussion, and use some WFDS, show how to use WFDS inputs and get information from a WFDS run to help with your to use in FlamMap. And while I'm not going to cover IFTDIS, the same can be done with IFTDIS. All the runs that are done in IFTDIS, you can download your landscape file from IFTDIS and your input file from IFTDIS, and you can use that within FlamMap. And the IFTDIS help has their help content has some good tutorials on what you need to do to get IFTDIS data and use it into FlamMap. So FlamMap is kind of a little bit of I say back to the future, because Farsight and FlamMap came along and they've been developed to develop near-term and WFDS applications as far what used to be desktop Farsight. And then most of the other applications that are in WFDS, short-term and basic, are all come from FlamMap. The science, the development, the application, improving and testing, and all that is coming from FlamMap. IFTDIS is the same. Their landscape fire behavior and their burn probability that they do are all from FlamMap. And we're trying to keep all of these different applications in sync. So as we do work in FlamMap, we work on with those other applications, trying to update them and keep them up to date and bring them up to speed, so that all of our modeling is on the same page and using the same sets of codes, same applications, with a lot of the same practicality of using them. I want to just talk about this one little equation here of modeling sources of error. And I think it's important to think about this in the context of how we're going to talk today, of everything, talking about some data errors. There's issues with the model, because FlamMap is just a system made up of a variety of models to help us get to the outputs that we want and to model the fire behaviors that we want. But all those models have limitations and assumptions associated with them that affect or control what you get out of it. Data is a big thing. Data, I would say, when I'm helping people with FlamMap issues, that I would say that probably 70 to 80% of the issues that arise are issues related with data. Bad data, skloogy data, shoddy data, inappropriate data, and then trying to feed it into a model, into the FlamMap system. And then user error, even for me, forgetting some of the limitations and assumptions of the model, still messing up data, putting it in here and forgetting about how all these things interact, either data and user and model, or this area here where all three come together. All those things, data plus user plus model, equals DUM, DUM, and it's always something to keep in the back of your mind. Whenever I've started to kind of preach this mantra whenever I'm talking about using FlamMap, is to keep these things in mind. Data, what you're doing, what your understanding is, and the model. What's the limitations, assumptions of all the models, and what do you get out? So that, I would just say, if there's a modeling mantra to keep in mind, it's this really complex equation right here. The next thing I want to talk about is how to and where to get FlamMap. If you come to the Missoula Fire Sciences Laboratory webpage, there's apps and products, and you can pick fire behavior applications, hit apply, and it will limit to the fire behavior applications. But everybody's work from the lab that's done is listed here, and you can get to direct to those anyway. If you filter it on that, you can go FlamMap and get to the FlamMap webpage. This is the homepage for the web for FlamMap and its application. And I just want to point out a couple things here. If you scroll down through here, there's general information about the model. There's some links to Landfire because we're highly dependent on Landfire data to run it. There's a link here to WinNinja and its application page because we've embedded WinNinja into FlamMap. There's some screenshots and information, and as you scroll down here, there's audio and video. So I try to post recent webinars and that I've given, and I've given a couple here in the last, since the end of June. This one you can link to is showing how to use the Landfire's data delivery system in their web viewer to get to data and download data and how to get it into FlamMap. And then there's this one that I did just last week, which is a more general overview of FlamMap that goes into some pretty more details about the help file and etc. It's more general in nature. The other thing I want to make aware of is how you get to download the data here. And that's over on this left-hand side. If you scroll down, you'll see documents and downloads. And if you click on this, this will give you a zip file that you can download, and depending on the browser you use will determine how you save that file. We always try to show the recent build date and the date and the version of it. If you want to see more information, really, you can go here. You can still get to the same zip file, and there's two sets of instructions in the zip file. And once you download and unzip the file, you'll have to look at those specific to your environment. If you're Forest Service, there's a specific set of instructions. There's a general set of instructions for the public at general population at large. And for DOI, you're gonna have to probably just work with your local IT people on how you install it because your situation is completely different. I also wanted to highlight that there's some live links over here that take you to some tips and tricks or some quick guides. I'm just gonna click on this one right now to show you, but spend some time. This one talks about data file management and some suggestions and best practices. You'll see I have embedded some links in here like how to get IFTDIS files into FlamMap. And there's some other information in here on how to share FlamMap projects and that. So I think hopefully this document is a worthwhile document to use. And so with that, just that quick overview, we're going to move into FlamMap itself. So I have a version of FlamMap, as you would suspect. I have the current version. This is the current version that's available for download on the Fire Lab webpage. And as we go through this today, I'll show one issue that's come up, which was an oversight on my part that we didn't get that didn't make it into this next release, but I'll show you how to work around it. And we will have another update to that quickly. But if you're on a current fire and you need something, you can always ping me on email and through my email on the Forest Service page. It's on the FlamMap webpage. So when you first open up FlamMap, this is what it's going to look like. It's going to open with a blank view and with nothing loaded in it. The first thing I want to point out too is that all these menus, every one of these menus has links to get to some place in the application. We also have some buttons. Anything that's grayed out isn't available because you need a landscape to be able to run. The first thing I want to talk about though quickly is just the help file. If you click here, we have a link to the web, and we maintain our FlamMap. Our help is accessible only with a live link at this time. You have to have an internet connection. But I want to just point out that we have all these topics here. And if you haven't spent any time exploring the help or navigating in the help or using the help, I highly suggest you spending some time. We even have a set of tutorials here that go through various how to use the help and moving around and thing. We have a section on FlamMap that goes over how to do MTT runs and basic runs, and a whole section on on using Farsight. And when you install the program, it has a set of example data that you can use to work through and that. So if you haven't spent any time in the help, please do. We spend a lot of time and effort trying to keep it up to date to make it usable. There is no user guide specific to FlyMap. This is it. But we have tried to keep it up to date and do the best we can to to hopefully answer your questions in here. Okay, so one of the big things I mentioned was get landscape. So, and this is a new utility that we're using, that is taking advantage of the Landfire Product Services. They've have they have created a product service that allows us to build into their system to grab landfire data, is pre-constructed landscapes that we can use within the FlamMap application. And we're leveraging that to help assist with getting information or getting a landscape into FlamMap. This link that I quickly went to from the Landfire page, they have a user's guide that goes into more information. And there's a product table, and Nicole Viant of the IFTDIS group and the RDNA group has been instrumental in helping getting this user's guide put together, along with some others. So we're highly leveraging this as a way to automate the acquisition of landfire data. So how do I get to a landscape or grab a landscape if I don't have one? So off this utilities menu, there's several utilities, and one of them is get landscape. So when you install FlamMap 6.2, if you follow the instructions and use the FlamMap setup exe, it should install everything you need to make this utility usable. So get landscape, we've made it so as several ways that you can get to a location. If you know the coordinates of the bounding box in WGS 84 coordinates in decimal degrees, you can enter them here. If you want to, you can zoom in and you can change the map view from a Google map to a Google Earth view, blue box, blue marble view. If you have once you have some runs or have required landscapes, you can get get a history and re-pull from others. And I want to point out that all of, all of these you can adjust just by grabbing there. You can stretch the box to make it more viewable. All these columns you can stretch and adjust them the way you want. You can also sort some of these based on the resolution, for example. And you can load previous ones just by picking select one that you've already done. You can sort it by date and time. So there's lots of ways to get around and get data from here. I'm going to just start from scratch as if I need a new landscape and I don't have one. So I'm going to zoom into an area that I want to get to. And the first thing I need to do is tell it where I want to go. And give it a name. I'm going to call it Blue Mountain Example. We have multiple versions of landfire data available here. They're all given by the same naming conventions that are on the landfire webpage. As things become available, we add them. So like right now, the most current version of landfire 2020, version 2.2.0 for CONUS and Alaska is available here if you need it. I'm gonna grab from 2019, the remap. We have given you a way to change the raster resolution for your landscape in various resolutions. I'm gonna pick just 30. And now I wanna draw my box. And I'm gonna draw that box. But if I don't like that box, I can edit it. I can grab it here, I can move it around to wherever I want it to be. I can stretch it and pull it and change the box the way I want. If I save it, I can do that. I can also, if I'm out of the edit mode, I can pan and zoom this as well so I can see where I'm at. And then I'm gonna say get landscape. And now we're reaching out and we're dependent upon an internet connection for you to do this. We're also dependent upon their system to be working and up and running. So right now, everything's working, but if you go to there is a potential shutdown coming for landfire data access over this weekend as they do some update and maintenance on the system. I guess while that's running, if there's a question right now while we're waiting for that, if you can ask Wes of it. Always the danger of doing live. Hey, look at that. So now I just say, okay, if I click on this open file, it'll open up and navigate to where I save that file to. I'm gonna move it though, because I didn't put it quite where I wanted. So you have to extract it. If you just do You'll see it here. Here's the landscape file. It saves it out in a GeoTIFF format. And the other important thing is it saves it out in a custom projection so that it meets the requirements of a top north up projection for using a landscape in FlamMap. There's information in this aux XML file about that landscape. It will tell you that it came from the product service, and it will tell you which bands and which data source is being used from the Landfire product service. So, and the bands are in the order that they would expect to be in a landscape file. So here's slope in degrees, aspect in degrees, band 4 is the fuel model, and so on all the way down through the 8 bands. So once I've done that, I can close this, and now I'm going to load that landscape. And there's our landscape file for the area that we went into. Other things that are useful to look at here is you can export that landscape out as a KMZ. If you haven't done that before, it's an easy way to bring it into Google Earth and take a look at it. You can change whatever layer. We default it to show fuel model, but you can show whatever model you want, whichever data layer you want, aspect, canopy cover, fuel model. You can't query in here because they're basically just images, but we do give you some information about that landscape. Its latitude and longitude bounds, the cell size, how many rows and columns of cells it has east and west, east and north, the units of every data theme within that landscape. So you can do everything that you can do in Google Earth: tilt, rotate, make it transparency, evaluate that landscape to whatever the is for Google Earth. So it's just a quick way to maybe critique and look at your landscape. So, and we'll come back to this later. Querying, of course, on the landscape gives you information. And then I also like to point out we have 2 different types of critique files to look at your landscape to be able to so that you can look at your landscape. So that happened off my screen almost instantaneously. And what this does is, just like a landscape critique in IFTDIS, gives you information about the ranges of the data themes present, what the projection is that it's in, and information about the distribution and frequencies of the individual data themes, as well as relationships amongst fuel models and their associations. If you want to see a little bit different look at it, you can get a PDF version of it. And now you can look at the same types of information, but we offer some graphing relationships of each of the data themes plus each of by a fuel model and the associated themes within that fuel model, by slope, aspect, its canopy cover, its stand height, and all that. So there's another way to critique and look at your landscape. Okay, so now I've decided I want to do a run, but I'm going to add some auxiliary vector themes here. And I'm going to add a RAS, a couple of fires here. And all those are showing up here. This is the Black Mountain fire. And if I can change the properties to that. Just so it shows up a little bit better for me to work with. So I can look at and see if fires have been accounted for. We can kind of see the fire scars and what they've put in. Now you as the user have to decide whether the land fire calls are appropriate or if they make sense or if you want to change them. So I think the first place to start out is with a basic run, or what we call a FlamMap run, and just a base fire behavior run. So fuel moisture files, the first thing you need is a fuel moisture file, and those can come from all the sources that you know to develop that information for fuel moistures. You can use fuel moistures from completed WFDS runs if you want, or you can create a fuel moisture file right here. So I'm going to create a fuel moisture file, and I can set what I want these values to be globally across the landscape or for every fuel model. I'm just going to change these. Say okay, and here's my fuel moisture file. You can see that it's by each individual fuel model that occurs in that landscape has been assigned that global value. But if I want to, I can change it here. If I decide I want that to be 60 and I want that to be 90, and then if I just save as, and now it's there, but I can always come back and change it. The other thing I need is wind direction. We offer you many ways to get to different winds. You have to decide as the user what's the most appropriate wind of concern and where the direction it's coming from and the speed associated with it. I'm going to put in 12 from 270. We can also, like I said, we've also generated Wind Ninja, and for here, if we do a generate gridded wind, we have Wind Ninja embedded in, and it's going to use this wind speed and azimuth to help you set up a Wind Ninja run. So if we just do Wind Ninja options, we can do a little bit more setting control. We limit the number of cells in a landscape that it's going to run Wind Ninja on because it's running it for the entire extent of your landscape to 1 million cells. If you have more than 1 million cells, we'll change the raster resolution to get it below 1 million cells. This million cell figure is because within the desktop application, we found that a lot of times if you have more than 1 million cells, depending on the individual's computer, it may run out of memory and it could cause the program to crash. So we've tried to control what that is. You can use diurnal simulation if you want. The thing is you have to tell it, if you click it this way, you have to tell it what the air temperature is, the cloud cover. That's the longitude's going to come from your clock, come from the center of the landscape that you're using. The calculation date time is going to appear based on your clock setting on your computer. And then if I really don't really know and I have more questions, this is a good time to point out that almost in every dialog box and window, we have a link to the help that will take you right to that point in the help file and help you work through questions you might have. And every one of these links is a hyperlink that will take you to another place in the help file. For now, I'm not going to use, if I had a conditioning period or a weather stream here, I could use the end of the conditioning period to set all the weather, air temperature, and cloud cover values. I have to give it foliar moisture and also right here, if you can run WinNinja external to FlamMap. And the reason you might want to do that is because the version of WinNinja we have just has the momentum solver, not the full mass and momentum solver. And again, that's for computation time. But if you run WinNinja external to FlamMap, you can load individual wind directions and grid themes from here. If I want to take a period in time. And this is the error I was talking about that we've fixed. There's an overlap problem, or how we're reading the input files coming from WinNinja. When they resample may not always overlay, but we've fixed that issue already, and hopefully this week there'll be a new release with adjusting for this problem. But the way around it is you can add. You can see in this case, what happened was I had a smaller landscape that I ran the WinNinja on. So that's why that overlap error is there. I'll give you another example that's a little bit better with that bug. I have to tell it what crown fire method I want to use. And then if I want to use fuel moistures from a fuel moisture file or use a weather stream file. So if I just use this, it's going to use whatever fuel moistures I have in my fuel moisture file. And going to use all the wind directions and everything from this weather stream. I'm going to add a weather stream here. And I'm going to add a weather stream because I want to recreate something that happened in 2017, which was a big fire year. And I want to show here with this that you can change and stretch these windows and move them around. I want to talk about graphing here so that you can see that we have a way to graph your weather so you can quickly look at your weather streams and your wind speeds and all that, so that you can look at relationships of temperature to RH and if they make sense. Look at the wind speed and direction and the cloud covers, just as a way for you to work through this and kind of critique and look at your weather data. And the graphing is a way to do it rather than just scrolling through this massive list and looking at it. So I'm going to pick a conditioning start time. And this is something that I like to stress too, is that when you're looking at your weather stream that you're using and the times, setting these start and end times is critical, right? Starting at midnight might be okay, but I can also start at 6 in the morning. But I'm not going to start, in this case, it's a basic fire, right? So I'm running everything across the landscape as spatial behave. So I'm not going to have a temporal component. I'm going to run it across the landscape under a set of conditions. Now, I'm probably not likely wanting to use midnight or 11 o'clock at night as my start time. And I'm going to reduce the amount of time that I'm doing the conditioning, and I'm going to change it to start at 1400. So it's going to start on the 30th at 06 and end at that. So it's everything, it's ignoring this data before the start time. Everything in green is the weather that's being used as the conditioning period up to the time I'm going to start it. So here's the starting time of this run. So we're looking at a wind from the north at 9 degrees, RH at 28, and the temperature, because I expanded that, is going to be like 85 degrees. I'm going to say save and close. I'm going to give it a name. Now I'm going to tell it what kind of fire behavior options I want. I'm going to just pick rate of spread, flame length, crown fire, and some max spot vectors. I'm going to say apply and launch. So remember, in the run that I just did, it's like running spatial behave. We're calculating the fire behavior under those conditions I gave it: fuel moistures, wind speeds and directions, and the weather conditioning across this entire landscape. If I do, here's the flame lengths, and we have some predefined legends. I'm going to use the hauling categories in feet, say apply. We've already bin these from the hauling categories that you know of 4 feet, 8 feet, 11 feet, 20 feet. Here's the range of flame lengths in feet across the landscape. And if I query on a point on the landscape, I can see all the values associated with that run output right here. Here is crown fire, and if I look at properties, it's the classes of no fire activity calculated, which is these areas that are classified as urban non-burnable, surface fire, passive crown fire, and active crown fire is the red. If I want to look at another way of looking at across this landscape to get some statistics, I can look at acres and see across this entire landscape, the acres across here by no fire, surface, passive, and active crown fire over here. And I can save this file out as a CSV file for later. I want to also talk about a run log. For every run that you do in FlamMap, you get a run log. And if you open it up, this run log has all the information associated with this run. It tells you where the fuel moisture file is, what RAWS file was used, what the fuel moistures were, any conditioning start period and end date. It lists all the weather stream data right here that was used. You can see the wind speed and direction, which I forgot to change and it left it at 0. So no wind speed, all from the north. See, so data this is the user error part of the dumb equation, where I forgot to go back and make sure I had everything selected. So if we zoom in now, we can see a little bit different here. Now we have some actual active crown fire across the landscape. And here's the run log again. This run log serves two purposes, one for documentation, but also if I save it, I can use it to use all the settings and everything to initialize a new run. So if I just say runs, import, and here's my example run log. We have a file filter over here that will filter for worthless files, which have a different extension. In this case, I'll do that one. And now I have a new run created here, and all the settings came along with that. So if I wanted to copy or change something from this, maybe I'll change it to 225. I can say apply, and everything else will stay the same, including the options I had and the outputs I wanted and how I had the model set up. So it's all right there. So that's a basic run. I'm going to open something that I already had. And then I don't know if there's any questions right now.
We had one question earlier, Chuck, but it looks like Stu grabbed it and helped Rocco out. He was having some issues with the install, but I think we're good so far. And I
Okay.
also believe we fixed the chat function so people can unmute themselves now if they have questions.
Okay. Thanks, Stu, for helping Rocco out.
We have one more question, Chuck, if you're at a place to answer it.
Yeah.
Okay, so Christopher Collins asks, when you're working under the wind and then diurnal settings, Did you say that longitude and time zones values were independent of one another?
I didn't say anything covering that at all. The longitude value will come from the center of your landscape. The this, if you use diurnal, if you that longitude value should come from the center of your landscape. The time zone offset gets used in relation to the longitude and latitude for solar angles. Um, in this case, I have a conditioning period because I have a weather stream in here. And I've told, if I say use conditioning period, now it will change to the conditions as of August 1st at 1300, which correspond to here. And it will grab the air temperature and the cloud cover from that weather stream file if I choose to do that. So they're connected, but the user has to set them here. If you do diurnal settings and use the weather model initialization in WinNinja, a lot of that information gets grabbed from the weather model that you pick to use to do the diurnal, include diurnal within WinNinja. So what I wanted to show here with this MTT run is a couple things. One, I'm gonna take this off. I'm gonna copy it and use it as a new run, which is another thing you can do to use a previous run that you have. I'm gonna say okay, apply. But in this case, here's my current fire, which is right here. So in a MTT run or a Farsight run, I need to provide an ignition file. And the way you can create shape files within the FlamMap application using creating point files, line files, or a polygon. So your ignitions can also be point, lines, or polygons. But if I didn't have this fire here and I wanted to make a fire, let's say I have a new one up here. If I just work my way around and left click, then double click, it's now created this polygon. And now I want to save that to a file. I can do save. And save it. And if I do options, shape clear, but if I want to add it in and see where it was, and I remember where I saved it to, it'll show up here. I can say change the properties again. And now there's that fire. And you can do the same with line fires. If I just draw one point, draw another point, double click, and now I can use this as a line ignition. I just have to save them. And then how you use those within FlamMap as barriers or ignition files, it just depends on how you load them within the application. Let's say I'm looking at this landscape and I know I don't have a recent fire that's occurred right here and I want to create a new barrier. So if I say, I'm just going to follow this fuel type change, basically. Oh, options. Clear. We can't have a mix. You can only have shapes, points, or I forgot to change to a polygon. So now here's this fire right here. We also have various line choices if you want to change how they're being displayed. So there's that fire. So I have a lot on here right now. I'm going to take that fire off. I've added the RAWs station that I'm using as a point file. So here's this RAWs file right here. I'm going to turn off that fire, and we're going to use this fire here as a setting. So I'm going to open up that copied run I made, and I'm going to up the wind a little bit. I'm going to generate gridded winds based on this entry. And now you can, I'm still under the million cell limit. So here's 30 minutes. I'm not going to use diurnal right now. I'm going to pick Scott and Reinhardt. I have to give it a full year moisture content. I'm going to say apply. I'm going to get rate of spread, flame length, and crown fire for the landscape calculated for this whole landscape at this point, but I'm also going to get some additional information. I have my ignition file, which is this Blue Mountain fire, which is right here. I'm going to add a barrier file, which I'm going to add open a shape file that I just did there. And add this fire right here. I also need to make some, and I'm going to fill that barrier because I'm going to say that it's so recent that there's nothing burnable within there, and it's going to be a complete barrier to fire spread. I'm going to ask for some of these outputs: rate of spread, arrival time, fire line, intensity, some of the flow paths, some ember locations associated with it. I also need to make some decisions on what I want to have for some of the model settings, how long I want, what the resolution I want it to be at. I'm going to leave it at the native landscape resolution, how long I want the fire to run. So in this case, it's going to be for 6 hours. The fire is going to run for 6 hours across under those constant conditions. I have to give it a spotting probability, and option that isn't used a lot by a lot of people is they don't mess with spotting delay. Spotting delay will impact how long it will take a spot fire to start if an ember lands on a receptive fuel bed. It will set a delay. If you have it as 0, it will it's almost an instantaneous start of that ember once it lands on a fuel bed. If you change this to have some kind of delay in minutes by 5 or 10 minutes, that long within the simulation time of its simulated 5 minutes in real time to before it'll ignite, which that means that spots or embers that land on receptive fuel beds close by will likely be overrun by the fire and never show, so never start. So it has a tendency, it will have the effect of changing your spotting and how it's used to simulate fire growth forward. I'm going to say apply. And because I've shown bad behavior and not checking all my inputs, I'm going to go back through and look at it. And I'm going to look at everything I got. And I think I'm good to go. So I'm going to come back to minimum travel time. And even though I selected these outputs from the fire behavior options, they're going to come along for the ride if I select them and launch MTT here. So now it's running through and it's doing Wind Ninja first. So it's having to calculate all the Wind Ninja vectors across this entire landscape. Then it was doing the fuel moisture conditioning across the landscape based on the weather stream file. And then it ran the simulation, and now it's writing all the outputs. So now all my outputs are shown here, and it's a mess of things, right? So if I look at the flow paths, I can see how all the flow paths came out across the landscape. And if I want to, I can change those properties too, right? If I want to look at the major paths, I can also change those properties if I want. I'm going to leave them yellow. And I can see how things moved across here. I can see that the fire hit in here and didn't move through the fire that I said was a barrier. If I add the arrival time, now I'm just looking at that arrival time output across here. I want to say that also here's the wind vectors. If I want to look at the Wind Ninja vectors that I ran here, they're all right here. And again, we have predefined legends. You can look at the and apply that across your landscape. So you can see it. You can export these out as a shapefile if you want, that you can bring in to Esri, GIS, QGIS, or any GIS product later for use. Same thing with the flow paths properties. I can save as whatever I want them to be. The key is, as you're working through here, whatever the legends are set up is how those will come out. We've added a thing where I can bulk export the raster outputs that come along. So flame length, rate of spread, fire line intensity, crown fire, so that any raster output, we have a batch. We can do raster outputs to GeoTIFF, and this will create a a multi-band GeoTIFF that you can use in GIS, but it keeps you from having to download each of these individually. And if you do decide to download these raster outputs like crown fire activity individually, you'll have an option to ASCII or GeoTIFF, and I would highly recommend GeoTIFF. I also can do a KMZ output of this run if I want it. And I'm just gonna see.
Chuck, I think we may have lost audio on your end.
Nope, I'm just not talking for once.
Okay, just checking. Thank you.
So here's the example that the MTT run I just did. It's right here. I can see where the fire was that started. Here's the barrier for the fire that I made up that worked, that I said was a barrier to fire spread. I can change any of the I can overlay landscape values if I want on top of that to investigate. I can look at the wind vectors. Here's the wind ninja vectors for the entire landscape across that area, so I can see how they're flowing. I can look at ember outputs. You can see that in this case, these are embers that were lofted from somewhere back here that landed within this barrier. You can see that none of them took off and started as potential new fire locations. So again, there's a lot there to look at and to work through. One thing I really want to do, because is show how quickly talk about WFDS and how to get what you need to do to get a WFDS run into and I'm just gonna pick a fire here, and I just picked this fire randomly because it's a recent fire that's been done, and I'm gonna just pick a completed near-term run that I can find. Let's just look at a completed run. FS Pro rejected. So we're going to just pick this one right here. And I'm going to say view results. So if you're in with this, any basic run, any near-term run, any short-term run can follow this same methodology to download information to bring into FlamMap. So the first thing I do is go to results, and I can see that there was an ignition. And I wish I could bulk download these, but I have to do them individually. So I'm going to grab an ignition. I'm going to grab their barrier file, and I'm going to grab this analysis input file. And I would just save all of these right here. I'm just going to save them right there. And I put them into the wrong folder. The other thing I have to do is get a landscape. I need to get the landscape associated with this. So all I do is just download the landscape, and I'm gonna, because it's a complete and accepted run, I'm getting the landscape just as it was used in this example. Some other things I often look at is the editor to see what landscape rules were used. Because you can't save them as a text, I use screen captures to grab those. Same with some of the landscape information. I'll take screen captures just to keep those. I might look at the near-term information too, just to see what's in there. But if it's your run, you're going to know all this stuff. I'm not going to save that, but now I'm going to go to where because I messed up. The thing is, so here's the ignition file, here's the barrier file, here's the landscape file, and here's the input file. And this input file has all the information that was used in that run from all the model settings and everything. I'm gonna extract this ignition file. I'm gonna extract the barriers file. And if I have, I have a handout here that goes through this in a little bit more detail on how to go through this. So I'm going to start with a new run. And the first thing I need to do is load this landscape. I forgot to unzip the landscape. And it's still creating the landscapes in the old LCP style format. So here's the landscape. So I can look at it and remember it looks coarser, right? Because it was done at a 60-meter cell size, and it gives you some information about what landscape was used. And now I'm going to import the Farsight run or the near-term run information from that WFDS run. Again, I have to just come over here and change the file type. And now everything is here. Here's the fuel moisture file. I can see in this case, they just used a global fuel moisture file across the entire landscape for every fuel model. So those values are being applied across the whole to every fuel model, regardless of where it is or what fuel model it is. I can see that they use wind direction from weather inputs. Now here's the difference. WFDS doesn't currently have Farsight in it. Doesn't have Wind Ninja in it, but if I wanted to use Wind Ninja, I could at this point, and I could use the Wind Ninja. I can go to the Wind Ninja options if I wanted, do some adjustments. We have some changes we can do here on speed and tolerance. Again, if you go to the help file, you can get more information on how that's working. I'm gonna cut maybe a burn period off of here to make this run a little quicker. It's brought in all the model settings. The only thing it doesn't bring is because these are path specific. I have to tell it what ignition file I want to be using. And I would really suggest, like in this handout, we'll talk about truncating and shortening all these file names because they can be really long. And so it's brought everything else along with it from right out of WFDS. So you can, but here you have changes, and what you have to be careful with, just like where I just did FlamMap, in FlamMap here with Farsight, I'm using Wind Ninja. You can make changes to settings here that affect output, run outputs and simulation outputs that you cannot change or adjust or alter within WFDS. Now here comes the big drum roll. Once you say launch, you can see that it's telling you the current fires how many spot fires it's cumulatively dealing with. These vertices deal with the expanding vertices on the perimeter. How many vertices you have. Here's the spot fire count going up. And I truncated that to make it, by taking that one burn period off, I probably shortened it up. So it's not gonna match up exactly with what was in WFDS. But if we did WFDS, we did this everything exactly as in WFDS, the output parameters should match up pretty closely, except for the effect of spotting on with what's in WFDS. And I can change the properties of how I display the display everything. So now I'm just showing the perimeters by burn period and in increments of the final burn periods. Here, this was their ignition file. They changed the landscape to non-burnable, but this was what they used as their ignition. So you can see that everything is coming out off of here. If I want to see the wind vectors again, properties, I can just change those. And I can do, unlike MTT, you know, that was showing the whole landscape. Here now, when you look at the wind vectors, they're only applied or seeing where they were used within that burn period. So here you can see how the winds were coming up slope. You have this recirculation or eddy. There might be a ridge right here that's causing that, or viewable from a ridge. And again, you can export out everything as a KMZ file and look at it. And there's all these are, we can get a spot fire list and see their launch time, their land time, their flight time, how far they went. You can save out the spot fires as a shape file, just as all the vector files can come out. And with that, I'm at about only 10 minutes left, and I'll stop rambling. We can open it up for some general questions, maybe.
Thanks, Chuck. We got a question from Diane Abendroth. Diane, did you want to try to ask with your mic on?
Hi, Chuck. I'm referring back to that last MTT run that you did, where you showed the arrival time and major paths. And I wondered if you could show us some hints for results like that would graphically maybe help distinguish the burn periods, or look a little bit more like the WFDS outputs that we're used to, perhaps. And then wondered about the major paths and ways to change the resolution of those so that you can see different levels according to the landscape.
Yeah, those are all
Thanks.
good questions. Those are all good questions. And a lot of those might be deep in the weeds part here, but let's try to do a new run, because I don't have that run to pull up anymore. So if what you're asking is how can I make some changes here? The one change that you have to decide on is how long your burn period is going to be and what you set that at. What that should be related to is the burn period that you're seeing in the fire that you're looking at. For sure, you can look at the arrival time in minutes, but when it shows the arrival time in minutes in a display, it's just it's displaying the arrival time in minutes based on how you decide to bin it and display it, right? So the maximum simulation time really affects how it's going to burn across the landscape, and how long across the landscape. So setting that time frame, using a run from minimum travel time, you could look at the arrival time compared to other perimeters for that same fire that you have. But the problem is the fidelity of our perimeters that we get to compare to are on the matter of hours or day on a daily basis, and not at the same fidelity. Now you could maybe use the output from a minimum travel time run and use it in, well, here's this one. That's the one we just talked about as a KMZ file. Maybe you could use these minutes and the arrival time here and let's pretend these yellow dots instead of spots are viewers locations or fire guard. So maybe you could change settings on duration based on that to look at burn periods and how long it's taking if you had a sequence, and maybe you can change those, use that to help you with that. The big thing I see is this value here, and I have better examples to talk about this, but an interval in minimum travel time. If you're starting out with a really small fire and you're doing it for that this value here may not display enough pathways for you, and you may have to decrease it, which is an option you can do in FlamMap that you can't do in WFDS. So did that kind of get at your questions, Diane?
Yeah, that first part, my question wasn't about maybe setting burn periods, but it was about displaying it in the outputs. And then the part about the resolution of the burn period or the major paths, that's what I was talking about, because WFDS has just a standardized one that doesn't show some of the detail that this might be able to do.
Yeah, so this setting here influences how it takes all the paths and the separation between all the paths to display it. So let's just do this, and I'm gonna just set spotting to 0. We'll see if this will show what you're talking about. So this one I did at 250 meters. So I'm going to copy that. And 500 meters, this 500 meters is what WFDS has. So we can, in this case, it may not be as pronounced as in other ones I've seen. But there's the 250 meters and there's the 500 meters. And so they're pretty similar, but to really do it, I'd have to bring them into Google and look at them, and then you could overlay them a little easier or save them out and load them as auxiliary themes and then change the order so I could look at them a little better. But they look like they're covering up pretty closely, but you're right. If you have a much smaller fire than this, you might not see all the pathways that might emanate from that, especially in WFDS.
Thanks, Chuck.
Yep. And we can talk offline, Diane, if we need to, and go through some other stuff to make sure I understood or addressed what you were asking.
You bet. Thank you.
Got a couple minutes left if anybody else has a question.
I have a question for Diane, because the question I get is about FlamMap in formal teaching, and it's not tied specific to a red card class. And I think for 495, you all have changed how you're gonna deal with WFDS and FlamMap. And Diane, do you want to talk about that real quick?
Right. So when we teach 495, starting this fall with the online material, and when we teach the in-class section of the course in spring, we will be focusing more on the WFDS application. But for the online portion, we will go into some detail with FlamMap and use it as our primary analysis tool instead of WFDS for both the near term and the short term style material. So that will be an opportunity for students to really get some practice being an analyst and working with this material. Really looking forward to putting that lesson plan together, and hopefully we can work together, Chuck, and ultimately provide that through your website.
That would be awesome, and I look forward to that opportunity.
Thanks for that, Diane. Carrie, I see you got your hand up. You got a question real quick?
Well, I have a general comment, and then I have a question for you, Wes. The additional capability and flexibility that this version of FlamMap brings to us is just incredible. It's like an analyst super toy. For those of us that feel like we're pretty adept at it, it just brings a whole new level of capability. And the question that I have for you, Wes, is To what degree do you think that we will see some of this capability and flexibility incorporated into WFDS Next Gen? And I mean by degree, you know, like some or a lot. You don't have to be specific.
Well, that remains to be seen. We're actually just now starting to build the user interface side of things for MTT, and we're just finishing up the FS Pro user interface. So I think we could have there could be a strong case for implementing, you know, more functionality in next gen. We haven't bridged that gap yet, but there's potential for it.
I would hope that it's a goal.
Okay, I'll keep that in mind. Thanks, Gary. Okay, everyone. Well, that concludes today's webinar. I really appreciate everybody getting online today and spending the time with Chuck here. Thank you, Chuck, for a great presentation. This was very helpful, especially given the fact that WFDS may be going down for a couple of days with the Arrows outage as well. So hopefully that doesn't impact us too long, but it's great that we have a backup that we can go to in the event that there are some issues with WFDS. The one last thing I'd like to add is these webinars that are monthly, we plan on doing another one actually in August. I got confirmation for it today. Looks like August 10th, we will hopefully be having a webinar on FireGuard data. I'm not sure exactly who's going to be our presenter yet, but we're working on ironing out the details now. So I'll try to get out an invite to everybody included in this list and our normal mailing list here within a couple days. Chuck?
Yeah, I just want to say that that was the purpose of this webinar, was to try to show that FlamMap can do what you need to do to help with fire modeling in the event of WFDS not being available. But there's so much more to talk about in this. We didn't even talk about weather streams and weather stream issues coming out of Fire Family Plus or getting forecasted weather streams. And what I want to say is that I'm Forest Service. My email is on, you can find it or Wes can share it. And if you have any questions at all, or you come across problems using FlamMap, to email me and reach out to me, and I'll work with you to help you in any way that I possibly can, so that everyone else can, so that you can be successful in what you're trying to do to support fires here. Even if WFDS doesn't go down and you want to use FlamMap to help support analysis on a fire or a project you're working on, don't hesitate to reach out to me.
Fantastic. Thanks, Chuck. And thanks everybody for joining. We'll catch you on the next one. Have a good afternoon.